Chapter 10 deals with energy economics, but before we look at renewable energy and electricity markets, we want to look at the background of energy. Global policy is set to prevent a rise in temperature from reaching 2 degrees Celsius, or about 400 parts per million by volume of CO2 in the atmosphere. Currently, the level is close to and maybe above 410 parts per million. Global greenhouse gas emissions, and basically we're talking about CO2 or CO2 equivalent emissions, are to be reduced by 50% from 1990 levels by 2050, although this is already out of date because we are now talking about net zero. In other words, global greenhouse gas emissions are to be reduced to zero by 2050. How did we get these numbers? Well, 2 degrees Celsius appears to have been picked out of the hat. In 2006, California's Global Warming Solutions Act and Executive Order S-3-05 began to set strong signals that we needed to reduce CO2 emissions. As pointed out earlier, at a 2009 meeting of the G8 in Italy, it was agreed to reduce emissions to 80% from 1990 levels by 2050. The EU objective was to reduce its emissions by 80 to 95% by 2050, but these kept being ratcheted down in terms of the target that was to be set. The Kyoto Protocol, COP3 of 1997, had an overall reduction in CO2 emissions of slightly more than 6% from 1990 levels during the so-called first commitment period from 2008 to 2012. It was relatively successful, as we mentioned out in a previous video, that it was successful because of the global recession, the switch from coal to natural gas in the US power generation sector, and other factors, including the shift or the inclusion of Eastern Germany into Germany and the elimination of many inefficient manufacturing and power plants in Eastern Germany. Canada, as a whole, failed to meet its 6% reduction target. The Paris Agreement of 2015, COP21, essentially retained the Kyoto process. Each country was supposed to provide intended nationally determined contributions, and the shaming was the main mechanism used to enforce compliance. It's still the main mechanism used to enforce compliance, shaming of countries that don't meet their nationally determined contributions. Every year there is one of these conferences of the parties to keep countries on track. Russia, for example, agreed to reduce emissions by 70 to 75% relative to 1990, and they hope to do that by 2030, or they stated they would do that by 2030. It already has 20 to 30% reduction in emissions, and the rest is supposed to be done through forestry activities. But it's, as noted, it's already 35% below 1990 levels. The US promised to make best efforts to reduce emissions by 26 to 28% by 2025 relative to a baseline of 2005. China agreed to begin reducing CO2 emissions no later than 2030, focusing on lowering emissions intensity, in other words, CO2 emissions per unit of GDP. Canada is expected to reduce emissions by 30% between 2005 and 2030. It is to do this by basically reducing coal, perhaps even eliminating coal-generated power, but heavily reliance on forestry activities. Now, if we look at energy sources, we see that there are a limited number. Non-renewable resources include coal, natural gas, oil, petroleum, and diesel. All of these come from petroleum. There's nuclear energy. There are renewable forms of energy such as wind, solar, hydraulics, biomass, geothermal, tidal, wave. Hydraulics means refers to hydropower. And then there's energy that we talk about quite a bit. But this is not an energy source. An energy can be blue, which is energy that comes from natural gas, which is hydrogen that comes from natural gas, or green, which is energy that comes from H2O or water. The problem is that a lot of electricity is needed in both cases to extract the hydrogen from the methane CH4 or from the H2O. Now, if we look at some trends, looking at CO2 emissions from energy consumption, processing, methane, and flaring from selected areas and the rest of the world, we see that Russia has pretty well stabilized its CO2 emissions. Japan has done the same. India is slowly increasing, this green line here. The United States has basically begun some reduction in CO2 emissions. None of that resulting as from policy, but rather from cheap natural gas replacing coal. The same thing with the European Union, which has been more aggressive at adopting wind and solar power and moving away from coal and possibly towards natural gas, except for the war in Ukraine, which shut off the spigot, and now the EU is relying on natural gas, liquefied natural gas from the Middle East and from the US. But the biggest thing here is this upward trend in CO2 emissions from by China, and of course the rest of the world as well, including Africa, but excluding India, as it's already included here. Global energy consumption reflects the same thing, but if we do it by type, we see that oil, so diesel, oil, any petroleum product, we see this exorbitant rise, and it's still the most important energy form. Coal, the same thing. Coal consumption has increased over time, as has natural gas consumption. These are the three dominant forms of energy use. If we look at others, nuclear increased but then remained flat and has declined somewhat due to the negative attitude toward nuclear power. Renewables has increased tremendously relative to where it was, but as a proportion of total energy, it remains very, very small and is about the same as hydropower. Now, if we look at renewables, they account for about 6.7%, now somewhat higher proportion of primary energy in 2021 compared to 6.8% for hydro. If we put things in perspective and get the scales right and look at percentage accounted for by various sources, we see that oil reached almost 50% back in the 1970s and has declined to almost 30% in modern times in the 2020s. Coal also has declined from about 37-38% down to about 27% over time. But some of that decline has been replaced by an increase in natural gas from 15% to 25% of total consumption of global energy. If we look at hydro, it's remained rather flat at about 6 to 7%, and nuclear has increased as noted before and then fell somewhat, so it accounts for less than 5% currently, and renewables have been increasing, but again they've only gotten to about 7% and no higher. If we look at the share of fossil fuels, which includes natural gas, oil, and coal, we find that the share has gone from just over 90% in 1965 down to about 82% in 2024. So it remains the most dominant form of consumption in terms of energy. And remember, energy is important because it's the main driver in an industrial society. If we look at the top 10 oil producers and the share of total world oil production in 2023, we see that the biggest producer is the United States, accounting for 22% of petroleum production, followed by Saudi Arabia 11%, and Russia slightly below that at 11%. Canada is the fourth largest producer at 6%, and we are trying to increase that by having pipelines going from Alberta to either the west coast or even towards the east coast. And right behind Canada is China, followed by Iraq, Brazil, and the United Arab Emirates, and Iran, all around 4% each, and Kuwait 3%. So these are the top 10 producers, and they account for about 73% of total production, or just over 100 million barrels per day, which is a huge amount. But notice that Canada is quite a bit larger than some of these other Mideastern states, such as Iraq, Iran, United Arab Emirates, and Kuwait. If we look at consumption and look at the top 10 consumers of oil in the world, we see that the United States is at 20%. Remember, it produces 22%, so it's a net exporter. China is at 15%, India at 5%, Russia 4%, Saudi Arabia, Japan, Brazil, South Korea, and Canada is number 9 at about the same rate as Germany. And these 10 account for 61% of the share of world total consumption. Coal remains the main source of generation for electricity, with more than 40% of global electricity generated from coal. It's ubiquitous, cheap, safe, but is the largest emitter of CO2 other than biomass on a per unit of electricity basis. Surprisingly, many countries continue to subsidize production of electricity from coal. And surprisingly, the largest coal exporters are Indonesia, Australia, the United States, Canada, Russia, and many developing countries. So developing countries tend to have a fair amount of coal available for producing electricity if they're able to come up with the funds to produce or to build generating plants. The United States and Canada intend to eliminate all coal-fired generation, although that has probably changed somewhat with the President Trump's administration. The problem is that even though these countries would eliminate coal-fired generation, they would continue to export coal, and in some years coal is the largest single commodity exported from British Columbia, ahead even of lumber, as we will show later in this video. If we look at coal consumption in selected countries and regions, this graph is a bit out of date, but it gives you the idea. Nonetheless, China dominates. It dominates everyone else. That the sum of the US, Europe, Japanese, and Russian consumption of coal added together is much less than what China itself consumes. And this slight downward trend has increased. There's been an upward swing again later in this series if we were to look at it. Coal consumption by China, as you can see, is larger than that of pretty well all other countries combined. Total consumption for all other countries without China is 1.864 million tons of oil equivalent, and China is at 1907 million tons of oil equivalent. If we look at BC and exports by major groups from 1988 to 2013, we see that forest products have dominated, although they have fallen in recent years and have continued a bit of a downward trend. but that energy exports, mainly coal, have increased over time, although they exhibit an up and down pattern as well. Agriculture and fish is fairly consistent. We also export various kinds of metals and minerals, and when we look at all other exports, we find that exports of staples, meaning agriculture, fish, forest products, energy products, and so on, exceed all other exports. If we look at Germany's attempt to wean itself off of electricity produced by coal, we look at a snapshot in January 2014, and things have surprisingly changed not that much since then. Nuclear energy accounts for the third highest amount of energy that's produced. Lignite coal, a really cheap form of coal that emits large amounts of CO2, was in 2014 the dominant fuel source for generation of electricity, followed by hard coal and then nuclear. Now these three are supposed to be eliminated eventually, including gas, so these four are to be eliminated, and you can see the problem that they will have because wind production here is very small. It's increased somewhat since in the past decade, as has solar, but these are very difficult, as we will see in another video. They're very difficult to increase. Notice that consumption was 46 terawatt hours, whereas production was 51 terawatt hours, with the difference of about 5 terawatt hours, approximately equal to the wind and solar, with wind constituting 12% of production and solar at this point of less than 2%. All right. So if we look at the British Petroleum forecast of global energy production by source from 2014 to 2035, which is a prediction. All right, we look at renewables. In 2014, they accounted for about 2.5% of total, they accounted for about 2.5% of production. They're only expected to be about 8% of total production by 2035. Bioenergy is going to increase slightly. Hydroelectricity also will increase slightly in terms of its contribution to total energy. Nuclear is expected to increase slightly as well. Coal is expected to go down, whereas natural gas is expected to go up and replace it. And oil is expected to go down slightly, with natural gas, again, one of the main factors replacing it. All right, these are in terms of percentage terms. And if we look at the growth between then, it would be, notice that each of these energy sources is expected to grow over time, with renewables expected to grow at nearly 8% per year, followed by bioenergy at 3%, hydroelectricity at less than 2%, nuclear at 2%. Coal is still expected to grow, although only at 0.5% per year, natural gas at almost 2%, and oil is expected to grow at less than 1% per year as well in these forecasts. If we look at a more recent prognosis of what the future will look like, we have three different scenarios that were considered. A central scenario where the growth rate of energy consumption falls from 2% to 1% after 2025. The new policies assumes full implementation of the Paris Agreement, and a 450 scenario caps concentration of CO2 at 450 parts per million to stabilize projected temperature increase at 2%, at 2 degrees Celsius. And you'll notice that in all of these scenarios, except for the 450 scenario, Coal is expected to increase somewhat. The same is true of oil consumption. Nuclear gas is expected to increase in all scenarios. Nuclear is expected to increase in all scenarios as well, with the greatest increase, of course, occurring in the 450 scenario. Hydro is expected to increase somewhat in all scenarios, but it remains small relative to the others. Wind and solar are expected to increase by the most amount, but even so, at 1.5, I guess this is in million tons of oil equivalent, it's still very small compared to the total, accounting for about 10% of the total production of, the total demand of world fuel for driving economies. So what do the shared socioeconomic pathways tell us about the future? Well, GDP is projected to grow at a similar rate to the past 25 years. So if we look at the world, it's about the same. Population growth is expected to be somewhat smaller, so productivity growth is expected to be somewhat greater than in the past. In China, there's expected to be no population growth contributing to GDP, but that productivity growth is expected to fall. In India, productivity growth is expected to remain about the same, with population growth falling slightly compared to the past. Africa, same story almost, except most of the GDP increase will be as a result of population, which is similar to what happened in the past 25 years. For the OECD countries as a whole, population is expected to be less of a factor in the increase of GDP than in the past, with productivity about the same as in the past. The same is true for other countries as well. If we look at increasing global prosperity that drives growth in energy demand, we see that GDP growth is expected to decline a little bit, and primary energy growth is expected to decline. The rate of increase is expected to decline over time somewhat. If we look at growth in urban population by region, we see that Africa is expected to increase the most, followed by China, India, other Asia. In fact, other Asia expected to be greater than India, and then OECD and other. Some other trends here is non-combusted use of fuels. So this is feedstock for petrochemicals and lubricants, and it's expected to grow in importance as well. But remember, these are non-combusted, so they're not burnt, they're just products that are used. Growth in passenger cars. All right, so the growth in the vehicle fleet is ICE, internal combustion engines, are expected to continue to dominate as a total, with plug-in hybrids and battery electrics slowly making inroads. Part of the reason is that the fuel economy of new cars is expected to decline sharply. As we can see here, the number of liters per 1,000 kilometers is expected to go from about an average of close to 10 in the US, let's say, to less than 4 in the US, and the same is true in China. The EU currently, its fleet already is less than 8 liters per 100 kilometers, and that too is expected to decline to almost 3 per 100 kilometers. We see here that the share of total power generation by renewables is expected to increase, but not greater than about 20%, with coal remaining a dominant source of fuel for power generation. If we look at the growth in power generation, we see that there's going to be reduction in some of the OECD, particularly in coal, but overall there will be an increase of 5 minus 2, about 3%. China will be well over 6%, as in India and other Asia, with most of that driven by renewables in both China and the OECD countries, less so in India and less so also in other countries where gas will become more important, both in China, less in India and other Asia, and important in other countries as well, with oil, mainly diesel, in other countries disappearing. Notice that coal is going to be a major driver in India and other Asia countries. If we look at shares of primary energy, we see that oil is going to decline, gas is going to increase, coal is going to decline, and renewables will increase, with nuclear and hydro remaining rather flat. And this has been the prediction through most of